Welcome to this explainer. Today, we're going to peel back the layers of a technology that is quietly but massively shaping our modern world. We're talking about data mining. We're going to explore this fascinating topic from the top down. We'll start by looking at its high-stakes impact out there in the real world, and then we'll journey all the way down into its mathematical core to see exactly how these incredible systems actually function. Whether you realize it or not, data mining touches almost every single aspect of our daily lives. And by the end of this explainer, you're going to have a crystal clear understanding of how the whole shebang works. Okay, so let's just dive right in with a question that honestly sounds like it's ripped straight from a sci-fi movie. How on earth can data foresee a crime before it even happens? Well, look at the Miami-Dade Police Department. They're utilizing advanced predictive analytics and hidden data patterns to do exactly that. By mining historical crime data, they're able to police smarter with far fewer resources. They're generating completely new thinking on cold cases and ultimately making safer streets for smarter cities. It's not magic, right? It's recognizing that the big picture starts small, finding those tiny, hidden mathematical relationships that lead investigators exactly to where they need to be.
Section 1. Solving real-world problems.
Now, law enforcement, that is just the tip of the iceberg. Data mining acts as an absolute hero tool across a massive variety of industries. The scale of this technology is staggering. Just think about retail and logistics. Companies are using data mining to completely optimize their inventory levels across different locations by predicting seasonal effects. In manufacturing, it's used to predict machinery failures before they ever happen, which saves millions in downtime. It's used in healthcare to aid in cancer research, in homeland security to track threats, and in banking to automate loan applications. Literally everywhere there's data, there are patterns waiting to be discovered to make our systems run smoother, faster, and safer. Take Visa, for example. We all know the credit card industry faces a massive challenge with fraudulent transactions, and they have to constantly balance security with actual customer experience. Well, Visa uses something called in-memory analytics to rapidly detect and stop credit card fraud. But here's the absolutely crucial part. They do this in milliseconds, without interrupting your normal shopping experience. They are mining the data of your purchase right as you swipe your card, comparing it against known fraud patterns instantly. Or look at American Honda. They're applying advanced analytics to a completely different kind of problem. They use data mining to find these hidden little patterns in customer reports and vehicle data. It's like a giant puzzle, and putting it together helps them investigate and process warranty claims far more effectively. By analyzing text and structured data, they can actually spot anomalies or widespread manufacturing issues early on, dramatically improving product quality and, of course, customer safety.
Section 2. Defining data mining.
So we know it works incredibly well in the real world. But if we peel back a layer, what actually is it? Well, in academic terms, as defined by Fayyad and his colleagues back in 1996, data mining is the non-trivial process of identifying valid, novel, potentially useful, and ultimately understandable patterns in data stored in structured databases. Notice the keywords here. It is a process. It has to be novel, meaning we're discovering something we didn't already know. And it absolutely must be understandable and useful so that businesses or organizations can actually take action on it. To translate all of that into plain English, data mining isn't just one single magic algorithm. As we can see here, it's actually a blend of multiple disciplines coming together. It sits right at the center of statistics, artificial intelligence, machine learning, information visualization, database management, and management science. It essentially takes the mathematical rigor of statistics, the brute computing power of AI, and the storage capabilities of data warehousing to make true knowledge discovery possible.
Moving on to Section 3. A taxonomy of patterns.
Now that we've got the concept nailed down, let's peel back the next layer and see exactly how we classify these predictive problems. This tree basically maps out the entire landscape of data mining. The crucial takeaway here is understanding the difference between supervised and unsupervised learning. On the top half, we have prediction tasks, like classification and regression. These use supervised learning. It's just like Visa training an algorithm on known fraudulent transactions to catch future ones, right? We train the algorithm on past data where we already know the outcome. On the bottom half, we have association and segmentation. These are unsupervised learning tasks. Here, the algorithm is just given a massive pile of data and asked to find its own natural groupings, kind of like Honda trying to spot new unknown anomalies in text reports without any prior training examples.
Now, looking at that taxonomy, you might be wondering, hey, how does this actually differ from traditional statistics? And it's a great question.
While they are very closely related, they aren't exactly the same thing. Traditional statistics often starts with a well-defined hypothesis and a sample of data to test that specific hypothesis. Data mining, on the other hand, is specifically built to uncover hidden mathematical or symbolic relationships within massive, consolidated datasets, often without a specific initial hypothesis at all. It's really about letting the data speak for itself to find completely novel patterns.
Section 4. The standardized process.
With the landscape mapped out, let's step right into the engine room. To move from art to science, you need a systematic approach. The most common industry standard for this is a 6-step process called the CRISP-DM framework, which stands for Cross-Industry Standard Process for Data Mining. It's a highly repetitive cycle. It kicks off with business understanding, basically knowing what the actual goal is. Then data understanding, followed by data preparation. Next is model building, where those algorithms we saw earlier are applied. Then comes testing and evaluation, and finally, deployment into the real world.
Now here's a genuinely surprising fact about that CRISP-DM framework. Out of those 6 steps, step number 3, data preparation, is so intensive and critical that it accounts for roughly 85% of the total project time. 85%! Cleaning the data, handling missing values, formatting it correctly, it is an enormous task. Because if you don't have high-quality data prepared correctly, even the most sophisticated AI algorithm in the world is just going to give you totally useless results.
Section 5. Evaluating algorithm success.
So after spending all that time preparing the data and building out a model, we reach the core of the onion. How do we mathematically know if these algorithms actually did their job? Well, we evaluate classification models using a very simple yet super powerful grid called a confusion matrix. This table essentially pits reality against the algorithm's predictions. If the algorithm predicts something is positive and it actually is positive, that's a true positive. But if it predicts negative and the reality was positive, that's a false negative, which, as you can imagine, can be a really dangerous error in something like medical testing. By plugging our test data into this matrix, we can calculate the true accuracy and hit rate of our data mining model, ensuring it's robust and absolutely ready for deployment.
As we've seen throughout this explainer, data mining is just incredibly powerful. I mean, it stops credit card fraud in milliseconds. It finds hidden cures in healthcare data. And as we saw in our sources, it's even an essential tool for tracking terrorist funding and catching criminals. But it leaves us with one vital, lingering question to ponder. As these algorithms get better and better at finding hidden patterns in our daily transactions and behaviors, at what cost does this all come to our personal privacy? It is a complex, delicate balance between safety, efficiency, and individual rights as we move forward into this highly analytical future. Thank you so much for joining me on this deep dive into data mining.